Okay, last session, 2.6 chapter review. Let's review all about last chapter, what we have learned. Okay, let's quickly review the summary of the key points. So we have to solve the equation, the quadratic equation by factorizing. Yeah. And remember the quadratic formula. And these two equations in form is about complete square form we call CSF, right? So this is fx. So we input function we call domain in function, right? And output function we call range. If the roots of the function value for x which fx equals 0, fx equals 0 means we have to solve that equation, so the roots. And we have to find the coordinate of our turning point by completing the square. Use this form to find the TP, the turning point. Okay. And finally is the discriminant. We use the discriminant to identify these quadratic functions can have roots or not. There's no root. So we use discriminant to find the root in the quadratic function, right? So maybe 1, 2, or no root. This depends on the discriminant. If discriminant greater than 0, they have 2 roots, 2 distinct roots. And if the discriminant equals 0, there's 1 and repeat real roots. If the discriminant less than 0, there's no root. Okay, let's quickly summarize what we know about last chapter. And then we have to do some exercise to enhance what we have learned from this whole chapter. You can stop this video and do some exercise by yourself and finally compare what's the difference between you did. Okay, let's do the first examples about solve the equations. And how to do this? We have to use the completing. So we have to use this formula, right? So we have to use the formula, right? Completing squared formed. Okay, so okay, let's do some practice. First, solve the equations. Solve this equation. First, we have to think about use the factorizing. So here we have to find 2 roots, 2 factor f1 times f2 equal, I say, can be 3 times minus 10 equal negative 30, and f1 plus f2 equal what? 16. So put in the linear equations can be, so this can be solved by f1, f2 equal can be equal by 2 and negative 15. Sorry, no, is negative 2, positive 15. So this equation can be rewrite by, can be 3x squared minus 15 plus 15x minus 2x minus 10. So it can be rewritten by, this is common factor about 3x x plus 5 minus 2 negative positive x plus 5 equals 0. And this common factor 3x minus 2 all square, 3x minus 2 brackets times x plus 5 brackets equal 0. So this can be identified. This will be 0, and this will be 0, can be changed to another equation. So 3x minus 2 equals 0, x plus 5 equals 0. Multiply, can simplify x equal 3 over 2. Oh, sorry, is 2 over 3, and x another root is -5. Okay, this is correct for you. Sketch the graph of equations. So we have to do what we have to do the first. CSF, completed square form, to find what? TP, eternity point. And 3, sketch the point, the graph. So y equal fx equal, we have changed the order, -4 plus x squared minus 10x plus 6. Did you remember another complete form square, like ax plus b over 2a all square minus c minus b squared over 4a. In here, a, we have to substitute the value. So a in here equal -4, b in here equal -10, and c equals 6. Put in this, substitute in this formula. So this function can be rewrite by -4 brackets x plus b equal -10 divided 2a, 2 times -4 over all square, and plus c in here 6 minus b squared -10 squared divided 4a, 4 plus -4. So this can be rewritten by -4x negative positive plus 10 over 8 all square plus 6 minus negative or positive plus 100 over 16. Okay, so the turning point, it can be negative and divide 8, and this is another point about 6 plus 16 over 100. Okay, so and a is positive, or a is a negative, sorry, a is a negative, so the graphs looks like here, right? So we have to find the eternity point. X in here, maybe roughly 10, and this is positive. Find this eternity point. So the eternity point, this is the maximum, right? Maximum point, also maximum point. Yeah, looks like this. Okay, example, to write expression by the form completed square form, where PT and PQ are constant. So we have to find the PQR's the value, okay? So this is quadratic equation can be rewritten by the functions can be, did you remember that? if the coefficient in A is 1, so we use this quickly formula, right? So it can be rewrite by x plus 12 over 2 all square minus, sorry, this I have a square, be 12 over 2 all square minus 9. It can be x plus 6 all square minus 6 square minus 9. It can be rewrite by x plus 6 all square minus 16 minus 9. So finally it can be rewrite by x plus 6 all square minus 45. So we have defined in PQRI px plus q square minus plus r. So p in here equal 1, right? And q in here equal what? 6, and r in here equal negative 45. Did you get it? Next challenge examples. You can stop the video and do some draft on your paper and finally compare what's the difference, okay? So find the equations fx blah 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 with k is a real constant, so k belongs to r. So A, find the discriminant of x in terms of k. So discriminant can be what? B squared minus 4ac. Do you remember that? So B in here is 4k plus 2 over square minus 4a means 4k, right? 4k say is 1 plus say can be 4k plus 2 all square minus 16k. This is A. Okay, B. We have to simplify the answer A, otherwise prove if fx have two discrete roots for all near zero root for value for k. To improve fx, the quadratic function have two distinct real roots, which means what? Discriminant is greater than 0. We have to do this equalities, okay? When we do the next chapter, we call inequalities. So in this formula will be greater than 0. So we have to simplify this formula. We have to first already open the brackets. So in here, open the brackets, 16 4k square plus 2a side 4k a side and 2 square minus 16k. So 16k square my plus is for 16k and plus 4 minus 16k. So 16k square, they are canceling, right? Plus 4, and this must be greater than 0. So put 4 into the right hand, so it's 16k square greater than negative 4. K squared will be 4 is 4. 16 can be divided by negative is 1 or 4, negative 4. So whatever k's number, k squared is a positive thing. Positives is over than negative. So whatever k belongs to anything, anywheres, any number that be over have 2 square roots. Okay. And I have to clean the screen. Okay, say explain why fx cannot be have two distinct roots when k equals 0. So we put k equals 0 into this formula, this form equation. So fx equal 0 plus 0 plus 2x in brackets plus 1 can be 2x plus 1. This is a linear equation, which means the graphs looks like maybe here the gradient is positive, so it'll be like here, up, going up. So there's only one root on the x-axis. So it can't be have two because it is a linear equation, not a quadratic equation. Okay? Thanks everybody for watching for this whole chapter. As previously I said, if you have any question, you can send emails to me, shulovesburgers@gmail.com. Thanks everybody watching. Thank you.